So for problem number 1, we're supposed to find the domain of a bunch of functions. For part A, f of x equals x squared plus 4x plus 5. This is a polynomial. And the way you recognize a polynomial is, first of all, you don't have any variables in the denominator. Notice there is no denominator at all, and definitely no variables in the denominator. And you don't have any radicals like square roots, cube roots. These exponents have to be to integer values, positive integers like x squared, x to the first in this case. And so whenever you have a polynomial, the domain automatically, in interval notation, is negative infinity to infinity. And again, if you explain why, you just say it is a polynomial. So there is no calculation to do for that one. For the next problem, we have a radical. And so anytime you have a even radical, so there's an implied square root right there, but if it's a fourth root, a sixth root, an eighth root, what you do is you take the argument, which is whatever's underneath the radical, x plus 3 in this case, and you set it to greater than or equal to 0. As long as the square root's in a numerator, like that one, greater than or equal to 0, that gives me x is greater than or equal to negative 3. Now this is the domain, but it's not an interval notation. So in interval notation, you know, you're talking negative 3 and everything to the right, because it said greater than or equal to. That negative 3 is included, so you're talking bracket negative 3 to infinity as your domain. For the next problem, we have a rational function. So remember, I mentioned for the first one, when you had a polynomial, I asked if there was a variable in the denominator. Look, there is definitely a variable of x in the denominator. So anytime you have a denominator, you must take that denominator and set it equal to 0 or not equal to 0 to find out where the function is undefined. So when I add the 1 over, I get 3x is equal to 1. I divide both sides by 3 and get x is equal to 1/3. So again, this is where the function is undefined. Now I asked you to write your answer in interval notation. So what you do is you take the values where the function is undefined, and there's just 1 in this case, and take that out of the domain. The domain is everything else. So when you write that in interval notation, it's negative infinity to 1/3, and then union 1/3 to infinity, or you can replace that union symbol with a comma, and it is still correct. For the next problem, we have another, I would say rational, because you have a variable in the denominator, but since there's a square root also, there's a little more that we need to deal with. If you'll recall from your notes, whenever you have a square root in the denominator, you do like we just did on the last problem, but instead of saying greater than or equal to 0, you do strictly greater than 0. Because you don't want it equal to 0, because that would make your denominator equal to 0. So I subtract 3 from both sides, and I get x is greater than negative 3. That is the domain, but not in interval notation. So I have negative 3. Since x is bigger than that, we're talking everything to the right and not including the negative 3. So final answer in interval notation is negative 3 to infinity. For example, E, notice we have a square root again, okay, but it's not in a denominator. So I take whatever's under the square root, which is 6 minus x, that's my argument. I set it to greater than or equal to 0. Again, if it's in from the numerator, you put the equal to with it. If it's in the denominator, like question D, then you do just greater than. Now, 2 ways you can solve this. One way is you could subtract 6 from both sides, and you get negative x is greater than or equal to negative 6. The problem is I have this negative, and to get rid of that negative, I need to divide both sides of this inequality by negative 1. But the problem is when you divide an inequality by a negative number, it switches the direction of the inequality. So what was greater than or equal to is now less than or equal to, and negative 6 divided by negative 1 is positive 6. That is my domain, but it is not in interval notation, so we're talking x is less than or equal to 6, which is everything to the left of 6, so that's negative infinity to 6 with a bracket. Question F. Now notice this time we have a cube root. Now the rule is when you have an odd radical, you can actually substitute any value you want to in there. The cubed root of a negative number is a real number, whereas the square root of a negative number is not, and that's why we only have to consider values greater than or equal to 0. So what do? You don't do anything. This is just like a polynomial. Your domain is negative infinity to infinity because you have an odd radical. You have a cube root. So that is your result. No calculation required. Problem G. Notice I have what's called a rational function. I definitely have variables in the denominator. I have an x squared and an x. That is one variable, but two different terms there. So what am I supposed to do? I'm supposed to set that entire denominator to equal to 0 or not equal to 0 to find out where the function is undefined. If this will factor, I should factor it. Now to factor this, I'm looking for numbers that multiply to be negative 21 and at the same time add to be positive 4. And we know that would be a 7 and negative 3, right? Check it. Multiplies to be negative 21, adds to be positive 4. So when I go factor, that's x minus 7 times x, plus 7 minus 3 is not 0. You separately set each one of those factors to not equal to 0 or equal to 0, depends on what you're more comfortable with. That means x cannot be negative 7 and x cannot be 3 when I add the 3 to both sides. Now this is where the function is undefined. This function is undefined at negative 7 and at 3. But now when I put it on an interval, an interval notation, and I put it on a number line, then it can't be negative 7, can't be 3, it can be everything else. So final answer, we're talking negative infinity to negative 7. That's this leftmost part. In the middle is negative 7 to 3. And then on the right is 3 to infinity. And again, once again, notice that I use parentheses instead of the union symbol. As far as I'm concerned, they're both correct. If you're using MyMathLab homework or MyLab Math homework, they want commas instead of the union symbol. For our next domain problem, notice we have two separate square roots, and they're both square roots. So these are problems we have to consider. You take the argument, which is x minus 1, set that to greater than or equal to 0 because the square root is in the numerator. And then you have a separate situation, x plus 5 has also got to be greater than or equal to 0. When I add the 1 to both sides, I get x is greater than or equal to 1, and I subtract the 5 and get x is greater than or equal to negative 5. Now, I need to consider both of these situations. The sharpest thing to do here is to draw two separate number lines and find out what's shaded for both. So if I'm saying x has got to be greater than or equal to 1 and negative 5, I really would like to put both of those on my number line. The first number line I'm shading in, the top one is x is greater than or equal to 1. So we're talking here over. The bottom one, x is greater than or equal to negative 5, here over. Now my final answer is only what is shaded for both. And notice the only thing shaded for both right here is 1 over. So when I write my final answer for the domain, we're just talking 1 with a bracket to infinity. And even though it's shaded on the bottom one, like for example 0 fits down here, 0 would substitute into the second square root just fine, but not into the first one, and that's why it has to make both of the inequalities true. Alright, we're almost finished. We have two more of these domain problems. So example I, we're dealing with I want to call it a rational function because it has the square root in it. It's not officially called a rational function, but it works like one. Now, we've got two separate issues. I've got a square root, so I have to set what's underneath the square root to greater than or equal to 0 because it came from a numerator. But I also have a separate situation that x plus 5 cannot equal to 0, right? Because that would give us our 0 in the denominator. So I keep these ideas separate until the very end. So x cannot be negative 5. X has got to be greater than or equal to 2. Let's consider that on a number line. And you can think about it as two separate number lines if you like. So the numbers I'm dealing with are negative 5 and 2. Might as well put that on both of my number lines. The first inequality, x is greater than or equal to 2, means I shade 2 over to the right. X is not equal to negative 5. I take that number out and I shade here and here, right? Now, what's shaded for both of them? Well, what's shaded for both of them is really just 2 over. So that's my domain. I can plug in numbers 2 and larger, and that's it. So the negative 5 wasn't even an issue. If I would have made that x minus 5, probably would have been a little more interesting. We would have put a hole in the graph at 5 and taken that out. And for our last domain problem, notice we have a complex fraction. So remember, the rule is you can't have the denominator equal to 0. So I really have two separate denominators. I know you see the first denominator, real clear, x minus 1. So I need to set that to not equal to 0. But there's also another denominator. How about this whole thing right here? That's also a denominator, and I have to consider that situation as well. So I also know that 3 divided by x minus 1 minus 2 is not allowed to equal to 0. So the first one's pretty easy to solve. Let's add 1 to both sides because x cannot be 1. We'll draw that on a number line in a minute. This one, let's add 2 to both sides. I have 3 over x minus 1 is equal to 2. Now that 2 is over 1, right? The easiest way to solve this rational equation is to cross multiply. 2 times x minus 1 is equal to, cross this way, 3 times 1, distribute the 2 inside, and solve for x. So I need to add 2. 2x equals 5, divide both sides by 2, x is equal to 5 halves. Now really I changed my not equal to equal to, but really x cannot be 5 halves. So if I think about that on a number line, I'm not really shading, right? Just x can't be 1. Here's 1. X can't be 5 halves, which is really 2.5. But x can be everything else. So we're talking negative infinity to 1, and then comma or union 1 to 5 halves, and then comma or union 5 halves to infinity. And that is my domain. And that's all of question 1. For problem 2, we're asked to find f plus g, f minus g, and some others, but I just have those two on this page. So first, let's take a look at f plus g. Now, by definition, what that means is f plus g of x, and we know that's f of x plus g of x. So these can be pretty simple problems where you just add like terms. In this case, it is. Look, f of x is x squared plus 2x minus 1. Notice I put parentheses around it, plus g of x, and I'll put parentheses around it as well, x squared minus 3. But actually, because we're adding, and we're just adding like terms here, because you have a polynomial plus a polynomial, the parentheses are not required. So I'm going to remove them and then add like terms. 1x squared plus 1x squared is 2x squared. 2x, and we don't have another x over here, so I'm going to bring down the 2x, and then negative 1 plus a negative 3 is negative 4. So f plus g of x is 2x squared plus 2x minus 4. Now let's do f minus g. The thing is, when students do, or anybody does f minus g, there's more trouble. And the reason is distributing negatives. So by definition, that's f of x minus g of x. The parentheses in this case are absolutely required. So I'm minusing x squared minus 3. Notice I put f of x first and g of x second. That's what's required when it's f of x minus g of x. Now, to remove the parentheses, for the first polynomial, I just drop them. For the second polynomial, since this negative is in front of the entire polynomial, I need to change both of those signs because I'm multiplying by negative 1. So negative 1 times positive x squared is negative x squared. Negative 1 times negative 3 is plus 3. Now I add like terms, x squared plus a negative x squared cancels. And then I bring down the 2x because I don't have another x term. And then negative 1 plus 3 is plus 2. So that's f plus g and f minus g of x. If we keep going and work on part C and then D, notice that I'm asking you to find f times g of x. So f times g of x, by definition, is f of x times g of x. Now, parentheses required here also. So x squared plus 2x minus 1 times x squared minus 3. Now, what we'll have to do is distribute. Now, the easiest way, I think, to do this is just to be sure you multiply each one of your terms in the first set of parentheses times each one of your term in the second. So, in other words, x squared times x squared is going to be x to the fourth. Remember, you add those exponents. X squared times negative 3 is negative 3x squared. Then I'm going to do it again with the next term. So 2x times x squared is 2x to the third, and then 2x times negative 3 is negative 6x. But I'm not finished, because I also have to multiply negative 1 times x squared is negative x squared, and then negative 1 times negative 3 is plus 3. And you certainly don't have to use all those colors to get it done, but I just wanted to show you what was what. So x squared times x squared is x to the fourth. X squared times negative 3 is negative 3x squared. Then I moved on to the middle term, which I wrote in purple, and then the last term, which I wrote in green. Now, when I combine like terms, notice I don't have another x to the fourth, so I just bring that down. I have a negative 3x squared here and a negative x squared here. Now, that's negative 4x squared, but I think I want to put my x to the third term next. There's only one of those, so I'm just going to bring it down, 2x to the third. Then I'm going to write negative 3x squared minus 1x squared, which is negative 4x squared. And then I have a minus 6x here. I'm going to bring that down, and then plus 3. And that's my final result for f times g of x. Okay. Next, I'm asked to find f divided by g. There we go. So part D, f divided by g of x. By definition is f of x divided by g of x. Thing is, g of x is not allowed to be 0. So let's keep going with that. F of x goes in the numerator, so that's going to be x squared plus 2x minus 1. And g of x goes in the denominator, which is x squared minus 3. Now, if this would factor and the denominator would factor, I need to do that to see if any factors would cancel. But there are not numbers that both multiply to be negative 1 and add to be positive 2. And the denominator is not a difference of squares either. So neither the numerator nor the denominator factor. But I also asked you to find the domain of f divided by g. So here's what I know. This is f divided by g of x because nothing canceled. But I also know that x squared minus 3 is not allowed to be 0, right? Because it's in the denominator. So to solve this, I would factor, but it doesn't factor. So we also have something called the square root property. Because there is no x term here, unlike this numerator here, if I were to set that equal to 0, you would either have to factor or use the quadratic formula. Here, I just need to add the 3 to the other side, get x squared equals 3, take the square root of both sides, that's plus or minus the square root of 3, and that is the domain. But remember, it can't be those values, so you're talking negative infinity to negative square root of 3, and then the middle part, negative square root of 3 to positive square root of 3, and then the last part, square root of 3 to infinity. That is your domain of f divided by g. Now, if you needed that extra bit of information of what does that look like on a number line before you write in interval notation, here's what we decided. Can't be negative square root of 3, can't be positive square root of 3, can be everything else. And that's how I got those 3 intervals that I wrote down at the bottom. And then for the last 2 problems, f minus g of 2 and g divided by f of 0. Okay? Now, think about the definition here. For f minus g of 2, remember that is not multiplying by 2. What that is f of 2 minus g of 2. Well, what does f of 2 mean? It means plug 2 into the f function. So that's what I'm going to do. Right back up here, I'm going to plug in a 2 everywhere there's an x. So it's going to be 2 squared plus 2 times 2 minus 1. Okay? I'm going to get that answer minus, this is telling me to plug 2 into the g function. So it's going to be 2 squared minus 3. And then I just need to work that out. So in this big set of brackets here, 2 squared is 4. 4 plus 4, that's 4 plus 4 minus 1, right? Over here, I've got 4 minus 3. If I keep going, 4 plus 4 is 8. 8 minus 1 is 7. And then 4 minus 3 is 1. And then finally, I can do 7 minus 1 is 6. So that's how you evaluate f minus g of 2. Just calculate f of 2, calculate g of 2, and subtract the two numbers. What about g divided by f of 0? It's the same idea, y'all. So g divided by f of 0 is g of 0 divided by f of 0. So first of all, I need to calculate g of 0, which means plug 0 into the g function. So it'll be 0 squared minus 3, and I'm going to divide that by f of 0, which means plug 0 into the f function. So it'd be 0 squared plus 2. Got carried away on the plus there. Hold on. 0 squared plus 2 times 0 minus 1. 0 squared minus 3 is 0 minus 3, which is negative 3. 0 squared plus 2 times 0 is 0 minus 1 gives me negative 1. And finally, negative 3 divided by negative 1 is positive 3. So g divided by f of 0 is positive 3.